Good morning, everyone. Happy Monday. I have a couple of announcements for us today. So the midterm date and time is October 15th at 7 p.m. We have a post on Ed about the logistics, what you can expect. For those of you, if you have a time conflict, we list the alternate time there. We'll have only one alternate time. If that doesn't work, then we'll need you to contact us. We're asking everyone to fill out the form found on that Ed post to let us know, just to confirm for us that you can make the midterm time, or if you need the alternate time, that you need the alternate time. If you are a DSP student, there's no need to fill out the form. We have your information already. Don't forget homework 4 due this week. Get 5 bonus points if you turn it in early on Wednesday by 11:59 p.m. Project 1 is now out. You will, we're expecting you to work on it in lab this week. So we give you time in lab this week to work on Project 1. The first checkpoint, which checks that you've gotten partway through the project, is due this week, the 24th. Show up at lab and you can have a partner in lab. Your lab GSI should write to you shortly to find out whether you'd like to work alone or like to have a partner and match you up with a partner. The full project will be due on October 1st. For credit, well, if you have a partner, please show up to lab so you can work on it together with your partner. The credit will be based on submitting the checkpoint. So if you don't have a partner, attending lab in person is not mandatory. It might be beneficial to you because we'll have folks there to help you if you get stuck. There is lab. There is lab. You'll go to your lab and you'll work on the project. But you won't have a separate lab in addition to do the project is instead of lab this week. All right, so our goals for this week. Today, I want to show you about some additional table operations called group, pivot, and join that are helpful for summarizing data in a table, forming an aggregate. On Wednesday, we'll look at a case study of combining all these operations to do more sophisticated data analysis of a data set. And one of the themes we want you to take away from this course is that by giving you these basic operations, these simple building blocks, if you then combine them in creative ways, you can accomplish much more complicated data analysis tasks. And then Friday, we'll start to shift gears and start to look at randomness, random experiments, simulation. All right, so we're coming to a close on this beginning section of the course where we focus on teaching you programming, tables, manipulating data in tables. Almost there. So first, let me show you lists. In Python, I have shown you arrays, which is a way to have a sequence of data. But Python also has lists, which are a lot like arrays. They're also a way to have a sequence of data. So there's a list that contains 3 numbers. A list has square brackets that indicates it's a list and with commas separating the items. What's unique about lists is that the elements of the list can be of differing types, can be of varying types. So in an array, all the elements in the array have to have the same type, like all numbers or all strings. But a list doesn't have that restriction. So I could have some numbers, I could have a string, I could have a float. And I get a list. And this list contains all sorts of different data in this case. And you can see here it's displayed, showing that it has some ints, it has some strings, it has a float. Okay, so those are lists. Lists are a way to store data in a sequence, and the values can have different types. When you create a list with square brackets, the items are separated by commas. And one thing I want you to notice from this example is that each element of the list, you can have any expression. The expression will be evaluated. So in this example, the first item is an int 5. The next item is a string. And the third item is a table. So this expression table.withColumn gets evaluated. It returns a table, and then that is the third item in the list. Now, one way that we're going to use lists in this course specifically is that you can represent a row of a table as a list. Remember, in a table, if you have a column, everything, all the items in a column need to have the same type. They'll be all the same type. But in a row, the items won't necessarily all be the same type. One of the columns might have a name of a state, and another might have the average income, and another might have the colors on the state flag. So there might be text and ints and floats in a row. So you can't represent a row as an array, but you can represent a row as a list. Also, you could represent a table column as a list, even though all the items are the same. You could have represented as an array or a list. So a column can be an array or a list. If you specify it as a list, the libraries will auto-convert it to an array. Lists, each item in a list can be anything. It doesn't have to be just a number or a string. It could be a more complicated object like a table, or it could even be another list, a list inside a list, or an array inside a list. So let's see some examples of this. Here is a simple list where each item is something simple, 4 items. But we could have a more complicated list. I create an array, and then I create a list with 3 items, and the first item in this list is that array. So when this gets displayed, notice what's happening here. I have a list with 3 items. The first item is an array that itself has 3 items. The second is a string, and the third is an int. So that's like an array contained inside a list. Remember I said that you can specify the column of a table as either an array or a list. Normally we've been doing that as an array, but you could do it as a list if you wanted. Here is a table you would get. The libraries are auto-converting that list to an array for you. They're expecting an array. They see you gave it a list, and they say, I'll helpfully convert that list to an array. Lists, you can use lists with these table library. One way that they're useful is to specify the labels of a table. If you're creating a new table from scratch, you can specify column labels, and there I have a table with no rows. Then now that I have this table with no rows, I can add a row. And the way you can add a row to a table, add it to the bottom, is with this operation with rows, with underscore rows. And with underscore rows accepts a list of rows. Okay, so you can see here, this is a list. The argument is one list. I pass it one list. That's a list of rows. So each item in that list is a row. And how is a row represented? Well, here's the first item in that list. It's the first row that we're adding. That row is itself represented as a list. So a list inside a list. Yo, dog, I heard you like lists. So this row here is going to have milk tea in the first column, Asha in the second column, and 5.5 in the third column, and so on. So let's look and see what happens when I add those rows. I've added 4 rows. Each row was specified as a list. I couldn't have specified the row as an array because it's not all the same type within a row. The with rows operations, like most of our other operations we're using in this class, don't modify the original table. They create a new table with some extra stuff added. So we need to assign that new table to the name drinks. Otherwise, it will disappear and we'll never be able to get to it again. Okay, so those are lists. We're going to use lists a bunch for representing rows.
Professor David, there is a large number of questions on if I provide a list of different types of elements into with columns, then what will happen?
Let's find out. I bet you bad things, but let's just find out and let's see. Let's try the same example, but I'm going to replace one of these numbers with a string. Oh no, the library let you do it, but that probably wasn't a good idea. So don't create tables like this. If lists can contain items of different types, then how does it get converted into an array, since arrays have to be one type? If your list has different types in it, you can't convert it into an array. But if your list has all the same types, like this list has all ints, then you can convert it to an array, and our libraries will auto convert it to an array. Are they all strings now? Ooh, good question. I should have checked that. Let's find out. Let's see. I guess I want t.where, maybe t.take 0. Good point. Okay. It's not as bad as I had feared. So if you look at this output, you see what's happened here in this table is this table, it looks like the number 1, but it's actually not. It's a string containing the sequence of characters 1. All right, so everything got converted to a string. And so now this column is indeed all of the same type. It's all strings. So correction. Thank you for that in the chat. But don't do that. You don't want to do that. Don't rely on this obscure. In general, when you're coding, if you're relying on some obscure behavior or some library, you are programming to 100% of your smartness. Don't program to 100% of your smartness, because finding bugs in your code and fixing them is twice as hard as writing the code in the first place. So if you're programming at your maximum IQ when you're writing code in the first place, if there's any bug and you got to go find that bug, it's going to take 200% of your IQ to find the bug. Yikes. Okay, write code that's obviously correct, not cleverly correct. All right, let's move on. So next I want to talk about cross-classification. This is a big fancy word, but it's a really common operation when you want to look at the relationship between two categorical variables in a data set. And that still sounds like a mouthful, so let me give you an example. Let's say that you're testing a drug on some patients. Then maybe you could classify all the patients as those who got this drug and then patients who didn't get the drug. You might also be able to classify the patients as patients who got better or patients who didn't get better. So those are two variables. Did they get the drug and did they get better? If you wanted to look at, if you wanted to break people into groups based on whether they got the drug or not, you could use the group operation. If you wanted to break them into groups based on whether they got better or not, you could use the group operation. But you might want to know what's the relationship between whether they got the drug and whether they got better. If people who get the drug do better, like recover more than people who didn't get the drug. So that's now about the relationship between these two variables. So that's what I'm going to show you how to do now. The group operation can be used to do this. It can group based on two or even more than two variables. So you can aggregate the rows, split them up into groups where everybody in the group has the same value for 2 columns or for any number of columns you choose. Okay. So if you call the group operation and you pass as the first argument a list of column names, then it will split them up using all of those columns. Once the group operation has split them up into groups, you can then summarize each group. It will summarize each group. By default, it'll summarize each group by counting how many items are in each group, how many rows of the table fall into that group. But sometimes it's useful to be able to summarize them in some other way. And so there's an optional argument, named argument, collect equals, where you can specify some other way to summarize the group. Like, for instance, taking the average value in the group, or taking the largest value in the group. So let's do an example. Let's look at the welcome survey. So we used this data set last time. Hopefully you're not bored of it yet. These are your responses to the welcome survey that you responded in, I guess it was homework 1. All right, so I was reading around on the web and I came across this question. Someone had asked, do right-handed people tend to sleep on their left side and left-handed people sleep on their right? I thought, oh, that seems kind of intuitive. Like, if I'm right-handed, maybe I don't want to, if I sleep on my side, don't want to sleep on my dominant hand. What do you think? Would you guess the answer is yes? No? Well, let's look at what the data from all of you say. All right, so now we're looking at the relationship between 2 categorical variables, right-handed versus left-handed, and sleep on the left side versus sleep on the right side, or sleep on some other side. Okay, so we can use the group operation to do that, but now we want to split this into groups based not on just what side you sleep on, based not just on whether you're left or right-handed, but based on both of those. So there's 2 columns that we care about. We care about handedness and sleep position. So I'm going to tell the group operation that I use both of those to split rows of this table. And I do that by passing a list of those rows as the first argument. That list could be any length. In this case, there were 2 columns that I cared about, so I'm passing the names of those columns. And here you can see the results are a count of how many people there were who had each combination of answers. So if we look at this, among the side sleepers, left-handed people were maybe slightly more likely to sleep on their left side. And right-handed people, if they slept on their side, were a little more likely to sleep on their right side than their left side. It's a modest difference. It's not a huge one, but it looks like there seems to be a difference here. That in fact, the answer to this question was no, it's the other way around. Right-handed people are maybe a little bit more likely to sleep on their right side. And for those of you who are curious, this is the same result I've gotten in previous semesters of Data 8. So I haven't found any documentation in the literature of this, but it looks like maybe there could be a pattern here. Kind of neat. All right, so that's grouping. Now I want to talk about pivot. Pivot is another operation for accomplishing the same goal. I want to look at the relationship between 2 categorical variables. So it's another way to achieve the same thing, but now the results are going to be presented in a little bit of a different way. So if we look here at this example, the resulting table had 1 row per combination of values. There might be a lot of combinations, so this table might get really long. So sometimes instead of having the combinations presented going down, Sometimes it's useful to have a 2D grid. If we're looking at the relationship of two variables, it might be useful to have a 2D grid where horizontally indicates the value of one of those attributes and vertically indicates the value of the other of those attributes. And that's exactly what the pivot operation is going to do for us. All right, so let's look at pivot tables. So the pivot operation lets us cross-classify to two categories. It has to be only two, can't be more than two. You can't have like a 3D table. And it's going to give you a grid. And each cell in that grid is going to correspond to a group. In other words, items that have a specific value for each of those two attributes. Typically, it'll be a count, but it could also be some other aggregate like an average or a maximum. The pivot operation on a table has two arguments. The first argument to the pivot operation identifies which attribute, which column label that we want to go horizontally, to be spread across the columns. And the second is which attribute or variable from the original table that we want spread vertically down the rows of this grid. Okay. Now you can optionally add two more arguments. If you don't add any more arguments, then it'll fill in this 2D grid with counts of how many items are in each combination. If you do fill it in, if you do provide these two optional arguments, then instead of counts, each of those groups will be summarized by some other aggregation operation, like the average. So the collect argument specifies what function it used to compute an aggregate, like np.mean says compute an average. And the values says which of the attributes, which of the columns for original table is the relevant data that we want to compute the average of. That is a massive mouthful. So we got to look at an example. So we're going to do this same example of comparing left-handedness versus right-handedness and what position people sleep in. But now I want to present it as a 2D grid instead of as a table that's going down. All right, so I'm going to call pivot on the original table of your responses. And the first argument indicates one of the variables I care about. The second argument indicates the other variable I care about. And if we look at what we get here, we get a 2D grid. And you can see that this summarizes all of your responses. So for instance, if you sleep on your back and you're left-handed, you got added 1 to the count in this cell right here. You were one of those 36 people. And if you're left-handed and you sleep on your left side, then you were counted towards that cell there. You were one of the 34 and so on. Okay, so the first argument to pivot indicates what side you sleep on. That's where you are on the horizontal, left to right. And the second argument is the handedness. In other words, that indicates where you are vertically, top to bottom. And you could locate your cell and it'd be like we took the class and we went out into Memorial Glade and we had you all go stand in the square that was allocated to your combination of sleep position and handedness. And then we counted how many were in each square. All right, let me pause and take questions here. And then we're going to do some more sophisticated stuff. What's the difference between pivot and grouping with two columns? Great question. The difference is between the top of the screen and the bottom of the screen. They do exactly the same thing. They just present the data differently. So for instance, you can see here the combination of left-handed people sleeping on their back. From the pivot table, you can see that's 36 from this 36 cell in the upper left of the pivot table. From the grouping operation, you can also see that's 36 from the first row of the group result, left-handed on your back, 36. So you can see it's the same numbers here in these two tables. They're just presented in a 1D versus 2D format. What about ambidextrous students? There weren't very many ambidextrous students, so I actually removed them from the data set to keep these tables simple. But if you wanted, you could redo the analysis looking at ambidextrous students. When would I use group versus when would I use pivot? Well, the most basic level answer I could give you is, do you like looking at your data in this 2D grid, or do you like looking into this in this 1D format? Choose whichever format you want to look at your data in. Okay, and then you can choose between group versus pivot. The other thing I would say, the other difference I would say is that pivot you can use for looking at the relationship between two variables. Group allows you to group by 1, 2, 3, 4, any number of variables. So if you have two variables you want to look at the relationship between, you could use either group or pivot, depending on how you like the result to be presented to you. If you have 1 or 3 or 4 or 5 variables that you want to group by, you can't use pivot. You have to use group. Finally, the last thing I would say on group versus pivot is that, as we're going to see in a little bit, sometimes the result of this operation is not what I want to look at. It's a new table. Notice how this is a table. So I can do new operations on this table. And then maybe the way that I'm going to get the result I actually care about is first doing a group or a pivot and then doing some more operations on that. So then whether you want to use group or pivot depends on what you're ultimately trying to achieve. And group or pivot might just be a step along the way. And I don't have a formula for you to choose between those two options. You'll have to think a little creatively if you're combining group or pivot with some subsequent operations. How does Python decide which column to take values from? Well, that's where the arguments to the pivot operation told it. In a pivot table, is there a good way to show what the column names represent, or do you just have to look at the code to see? You have to look at the code to see. Could I show an example of the optional arguments for pivot? Absolutely, I'll do that in just a moment. Is readability considered better for pivot? Well, you decide. In this example, I sure find the pivot readability a lot easier to read. If not specified, would either work? Yep, either would work. It's a matter of personal preference, maybe. For the group operation we did earlier, could we use array instead of a list? Probably. I don't know. Haven't tried it. Can you group or pivot more than 2 variables? You can group more than 2 variables, no problem. In fact, we can even try it. Let's look up another variable. First pant leg. Were those capitalized? Not capitalized. Okay. Also would help if I could, if my spelling wasn't pants. Yeah. All right, I grouped on 3 variables there. So you can see that each row represents a combination of all 3 variables. And you, when you responded, your count added 1 to one of the rows in this table. You fall into one of these combinations. So if you have more than 2 variables, you can absolutely group based on that. But you can't pivot based on more than 2 variables, because you couldn't fit it into a 2D grid. You would need like a 3D grid or something. And how would you visualize that? So pivot is only for 2 variables. All right. Yes, lots of questions asking, for example, of a pivot table using values and collect, these optional arguments. So let's do it. Let's do it. Let's first look at group, where maybe what I care about is breaking you down by sleep position. And then I want to summarize the people in each group by the average value of one of the other variables. So what does this table shows? This is split you up by what position you sleep in. And then we're showing here, for instance, the average extroversion level of people who sleep on their back. And then below that, you can see the average answer to the extroversion question for people who sleep on their left side and on their right and on your stomach. So these numbers here in this column, extroversion average, why might I be interested in them? What kind of question could they help me to answer? You want to paste in chat? Are outgoing people less likely to sleep? Almost, except sleep position isn't about whether you're more or less likely to sleep. Yeah, it's like looking, is there an association or a correlation between sleep position and extroversion? Like maybe, for instance, do people who sleep on their side, are they more extroverted than people who sleep on their stomach? And I don't know. I'm not seeing a huge difference here. So I might walk away saying there doesn't seem to be much difference. Okay. So this is generally when we're going to use these cross classification, is we're looking for an association between categorical variables, or in this case, between a categorical and a numerical variable. All right. Let's do another example. I'm going to group now, not just by sleep position, but also by sleep position and handedness. And then we're going to do the same thing as before. So we're now split this up into more groups. All right. And maybe I care about how many hours of sleep people get. So I don't care about things like the number of textees. So I'm going to select just some of the columns that I care about. And then I'm going to group by split people up into groups based on both handedness and sleep position. So the first argument to group is the pair of variables. And then you asked me for an example of using the collect argument to choose a different way to aggregate or summarize each group. So I'm going to do that with the average. And here we can see here we split responses up based on handedness and sleep position. And that gives a bunch of groups. And then for each group, what this did was it looked at the number of hours of sleep of all the people reported by all people in that group and took the average of that across the group. So this is saying that among those of you who are left-handed and sleep on your back, the average number of hours of sleep you report getting per night is 6.68 hours. Okay, so this might be useful if you thought that somehow number of hours of sleep was related to a combination of your handedness and how you sleep. You can also do this for pivot. So let's do the same thing. Say I don't like this presentation here. I would rather have this presentation as a 2D grid. Let me show you how to do that with a pivot table. So in a pivot table, you specify the two variables that we care about. We care about sleep position and we care about handedness. And then that's going to be used to break people up into groups. And then we're going to summarize each group based on the average of the value of numbers of hours of sleep. Okay, and now we get a pivot table that looks like this. So you can see sleep position was the first attribute, and that shows up in the horizontal part of this table. Handedness was the second attribute, and that shows up in the vertical part of this table. And then that's used to group people, to put you into groups. And then each group is summarized as an average number of hours of sleep. So here's how we told it we wanted to take an average. And then the values equals told us what numbers we want to take the average of. look in the hours of sleep column to get some numbers, get the numbers for all the people in the group and take the average of those numbers. So you can see here we have the same results as we got from the grouping, but it's just presented in a different way as a grid instead of as a table, a Bundy table. Can you do values equals NP.average hours of sleep? No, you can't. If you tried to do that, a human would understand what you meant, but the computer would not. See, here's the problem. The computer would say, well, you're passing an argument, this values equals argument. So to find out what you're passing, I better evaluate this expression. So it would try to evaluate the expression NP.average, where the argument is hours of sleep. What argument is NP.average expecting? NP.average is expecting an array. Here we've passed it a string. NP.average isn't going to know what to do with that. It's expecting an array. It didn't get one. It's going to scream bloody murder and not be happy with you. So it's not going to do anything useful. So this NP.average is going to give you an error or do something not useful. And then you pass values equals and you're already toast. So that's why we need this more complicated way of doing a pivot table. So yes, the collect equals NP.average is being applied to hours of sleep only, right? If you do a group operation, collect equals applied to every one of the attributes from the original table, all of them. With a pivot table, there's really no space to show that. You can only show a single number. So you can only apply NP.average to a single attribute from the original survey table. So you got to tell the pivot table which one to do the average of. All right. So now I want to look at a challenge question for you to think about, where we're now going to look at group and pivot is not the end goal, but it's a means to an end. It's a first step towards answering a question we ultimately care about. So I want you to think about these two challenge questions. Spend a little time thinking about the first one. You have a table called sky shown here at the bottom of the slide, and think about what operations you would do to answer the first question. In other words, to get a table that shows the answers to the first question. And if you think about that for a little bit, and don't type anything in the chat yet. And if you can figure out the answer to the first question, then move on to thinking about the second one. So your answer to the question should be some code that works with this sky table and produces a new table where you can read off the answers to the question. And I really do want you to think about this. Try to come up with some code for the question one. Do any of you want more time to think about question one? All right, 30 seconds more. All right, so maybe you could type in the chat how you would approach question one. We've been talking a bunch about group or pivot, so it's a pretty good guess there's going to be a group or a pivot in there somewhere. Oh, yes, lots of answers. Some variety too. Love to see it. Love to see it. All right, let's talk through how we might think about this problem. We're probably going to be doing some group or pivot. So maybe a first question to ask ourselves is, how do we want to split up the data into groups? What do we want the groups to be? Like one group per what? One group per materials? One group per city and material combo? Yeah. Yeah, we care about this combination of city and material, right? I don't want to know the tallest steel skyscraper in the country. I want to know the tallest steel skyscraper in New York City and the tallest steel one in Atlanta and the tallest steel one in Houston. So this question kind of forced you to think a little bit because it has a beginning for each city and at the end for each material. What that's kind of a clue is that we should take all the skyscrapers that are in the same city and have the same material and group them together. So all the New York City concrete skyscrapers form one group, and all the Atlanta concrete skyscrapers form another group, and all the Atlanta steel skyscrapers follow another group. So we're splitting up into groups, and the groups should be based on both city and material. So that tells you that what we're doing is we're looking at the relationship. We're doing cross classification based on two attributes, two variables. So now you might be thinking either a group or a pivot table. Anytime you're looking at these, splitting into groups based on two attributes. And we kind of know what a first start at maybe how we want to do this. So let's try, let's just try something. Try grouping, and we said we want to group based on both city and material. Let's see if that gives me what I want. Well, it's in the right vein. I'm getting closer. I've got the right groupings, but as I look at this, I realize there's something wrong. This is telling me there are 27 skyscrapers in Atlanta that are made of concrete, and that wasn't what I wanted. The question wanted to know what was the tallest building. So summarizing by count wasn't the right summary. I need to use a different aggregation function. And the aggregation function I care about is the height. So max height seems like. So maybe that's my next thought, is to try using max. But then as I do this, I might realize, well, I'm a lot closer now. This is a pretty good answer. You can see that I've broken this down into groups based on the combination of city and material. And I can read off the answer to what is the height of the tallest Atlanta concrete skyscraper. It's 264.25. So that is present in this table. But this table also has some extraneous data that's not really what I wanted. I don't care about the oldest skyscraper that's in Atlanta and made of concrete. That wasn't asked for by the question. So I should really get rid of some of these columns. So one way to do that is to notice that this is a table. And once I've created a table, I can manipulate it further using additional operations. So I can keep only the columns that I care about. And now I've got the answer that I wanted. Drop would be fine too. There's multiple ways to do this. Instead of select, I could have used drop. Yet one more way I could have done it would be to notice I don't really care about the name or the age, so I could have got rid of them right from the start. I only care about city, material, and height, so keep only those. Maybe we'll call this Sky2. And then now I can do my group on this table. All right, that also would have worked. So there's often multiple ways to do it. And in fact, I could have done this with a pivot table too, as some of you answered. Some of you pointed out I could use a pivot table. So the way I could use a pivot table would be to do pivot, and I care about the city, and I care about the material. So that's what I'm using to break things into groups. But I don't want to just count the number in each group. I want to use the average. So no, the max. I want to use the max. And then what do I want to take the max of? I want to take the max of the height. And so that would have given me the same answer with the same numbers, but now shown as a pivot table instead of a group. Great. So that's the first challenge question. How does Max find the number that we want to be maxed? Well, with a pivot table, it looks at this values equals argument. And that one told me, look in the height column. When I called dot group, notice what happened here. How did it know what column to look at? It didn't. So it did it for every single column. That was only useful for the height, was the only thing I really cared about. So I had to get rid of the other stuff I didn't care about. Okay, let's look at challenge question number 2 now. Challenge question number 2 says the age difference between steel buildings, oldest steel buildings and the oldest concrete buildings. This is much more challenging. So let me just show you the solution. The way you could think about this is start by asking, how am I grouping things? And you can see that maybe it seems natural to put the skyscrapers into groups based on their city and their material as before. Okay, so group them by city and material and find out how old the oldest skyscraper in each group is. And that would have all the data that I need. And then now I need to compute that differences. So I want to get the data into a format where it's easy to compute all those differences in one operation. And you could look at what we got from the pivot table and what we got from the group table and figure out which one's going to be more useful. So let's give it a try. Let's look at what would happen if I did this, but now it's age that I care about, right? So I've got a pivot table, but I'm going to do the same pivot table, but now I care about age. And I can do the same grouping, but now I care about age. Now I would like to look at the difference between the oldest concrete and the oldest steel building. So if I did the grouping, I want to know, for instance, for Atlanta, I want to know the difference between 44 and 123. And for Austin, I want to know the difference between 36 and 83 and so on. So I could do that with a calculator, but I'd be going down these 80 rows one by one. That's kind of tedious. I want to find a way for the computer to do that for me. And it's not clear what table operation I could do that would do those differences here. So next I look at the pivot table. On this pivot table, I see, well, for Atlanta, I want to know the difference between 44 and 123. For Austin, I want to know the difference between 36 and 83. That's kind of nice. They're lined up, but I'd still have to do these differences one by hand. I don't know how to get a new row that is the differences between two rows. But it might give you an idea, because one thing we do know how to do if you have a table is to get a new column that is the difference between two columns. So if we could just sort of swap this around, swap what were the columns and what were the rows, we'd be in great shape. So let's do that. And now we can see that we're in a happier situation with this pivot table. We want to know the difference between 44 and 123, and the difference between 36 and 83. So that's the difference between these two columns. Each column is an array, so you can compute the differences like that using array operations. All right, so we're now almost there. Now what we need to do, let's give this a name. Let's call this P for pivoted. P. And finally, what we're going to do is we're going to take the column for concrete, say steel minus the column concrete, that's the differences. And then we're going to get sky dot with column difference. And now we have these differences. And then finally, I could use select to keep only this difference column because that's the only one I care about. So that's how I could answer the challenge question. Okay, so what this illustrates is that you can combine group operations like group and pivot together with other things you've already seen how to do to enable you to do quite sophisticated data analysis with only a couple of lines of Python. And with that, we'll wrap up right here. If you need any help figuring out between the difference between group and pivot, we offer a visualizer on our website that will help you understand what group and pivot is going to do. You can click on the link and have a great day, and we'll see you in lecture on Wednesday. Thank you.